Problem number 10. A gorilla weighing 400 newtons is pulling herself onto a tree branch. Okay, so I guess this gorilla is doing some pull-ups right now. All right. Okay, so we have our gorilla, and she is currently doing some pull-ups, and no, maybe she's not doing pull-ups, but she's pulling herself up onto the tree branch. So she's hanging here, and she's about to pull herself up so that she's sitting on the tree branch. Okay, so once again, what's the downwards force acting on this object? That's going to be our gravitational force, right? And then what's she doing? Once again, she's pulling herself upwards. She's pulling herself onto the tree branch. So what's that force if she's pulling herself upwards? I would say that that's a applied force. Whenever we're dealing with a push or a pull, we're going to be saying that's an applied force. I'm sorry, I'm indicating that that's an upwards arrow right there. I know that you can't really see it. I apologize for that. Okay, so we have our applied force acting upwards, and we have our force due to gravity acting downwards. Are there any forces acting to the left or to the right of the object? No, we're just dealing with those two. Okay, so we're pretty much done with this one, except for the idea that we see that she's weighing 400 newtons. The newtons is telling us what? What is that indicating? Oh, that's a force, right? And if she's weighing 400 newtons, what is that force? That's our force due to gravity. Okay, and we're done with this one. But if we want to take this one a step further, so we have our force due to gravity, which is equal to mass times acceleration due to gravity. So if we wanted to calculate our mass right now, we could just plug this in and figure out our mass. Once again, we have our 400 newtons over here for our force due to gravity. Our mass is what we're going to be solving for, and we have our acceleration due to gravity of 9.8 meters per second. We're not going to be indicating that it's negative 9.8 because we are already indicating that it's a downwards direction for the force due to gravity. Negative 9.8 would indicate another direction downwards. So if we're accounting for the direction twice, that wouldn't be good. So we're just going to leave it like this as a positive 9.8 over here to not account for direction twice. So if we're solving this out for mass, all we have to do is divide by 9.8 on both sides of the equation, and we'll have 400 divided by 9.8, which gives us 40.8 kilograms. And that's it for this problem.